You're listening to the N2K Space Network.
Excitement guaranteed. That's the sound from SpaceX's Starship's very first launch for its first integrated flight test this morning. After a short delay, Starship successfully launched early this morning from Boca Chica, Texas. The Super Heavy boosters ignited in a dazzling display, nearly drowned out by the cheers and applause from Mission Control.
T-minus 20 seconds to LOS speed rest. Go for deploy.
Today is April 20th, 2023. I'm Maria Varmazes, and this is T-minus. Starship is meant to fly. Virgin Orbit might find a buyer yet. New campaigns and consortiums from ESA and NASA. A roundup of national security items from Space Symposium this week. And a discussion with Michael Madrid, Director of Strategic Relationships at Starfish Space, our T-minus launch partner. We'll be talking about in-space servicing, assembly, and manufacturing, and Starfish Space's recent Series A fundraising round. And lots more to come, so stick around. Let's get into today's Intel briefing. Our heartfelt congratulations to the entire team at SpaceX. Starship successfully launched and cleared Max Q. Though stage separation failed, main engine cutoff and the Super Heavy booster flip both succeeded. It was at that stage, roughly 3 minutes into flight, that, Starship entered its acrobatic era and became the amazing tumbling rocket. For about 60 seconds, the entire rocket did a series of acrobatic corkscrews and flips. It did a complete 1260, in fact. And at about 4 minutes into flight, a rapid unscheduled disassembly, initiated by the abort system, destroyed both the Super Heavy booster and Starship. The very fun video is linked in the show notes, and if you haven't watched the flight yet, you really should. You may hear some hemming and hawing over the fact that Starship didn't reach orbit or even space, given that it aborted at 39 kilometers. But today's test is a significant milestone for this program that will one day get the first woman and first person of color to the moon for the Artemis 3 mission. Lots of good data to come from this, of course. Design, test, and iterate. That's engineering, baby. So well done, and ad astra, Starship. To be or not to be, that is the question with Virgin Orbit. The satellite launch company officially filed a Chapter 11 bankruptcy plan on Wednesday, and on the same day they stated that they plan to launch again later this year. Virgin Orbit Holdings released findings from its failed UK launch in January, blaming a dislodged filter, and says that the issue has now been fixed and that they hope to return to the skies later this year. Virgin Orbit's CEO Dan Hart told the Washington Post that he has learned from missteps, which led the company to burn through hundreds of millions of dollars. The firm laid off about 85% of its 750 employees earlier this month, but despite that, CEO Hart says Virgin Orbit is in a lot of discussion with potential buyers. Will the now 100-man team be able to turn this Shakespearean tale around? We shall see. On to some off-the-Earth stories now, and the European Space Agency has launched a new campaign calling for space industry input on what natural resources it can use from the moon. ESA's In Situ Resource Utilization, or ISRU, program hopes to identify knowledge and technical gaps in the agency's current lunar resource value chain. ESA says natural resources from the moon, including oxygen, water, metals, and regolith, play a key role in in-space economics. The agency is already exploring applications including the refueling of spacecraft, life support systems, energy storage, infrastructure, and in-space manufacturing, and is looking for input on source extraction and processing, excavation, refining, and transportation, and storage and distribution, particularly of fuels on the lunar surface. The European Space Agency has also just announced 2 new contracts awarded to Arthur D. Little and Thales Alenia Italy to study space-based solar power plants. These studies represent the next big step in the agency's Solaris initiative, which is exploring solar energy for terrestrial uses. The goal of the Solaris initiative is to assess the benefits, commercial opportunities, and risks of space-based solar power as a contributor to terrestrial energy as part of a larger decarbonization plan for Europe. ESA hopes results from the studies will allow Europe to make an informed decision by the end of 2025. And NASA announced the creation of the Consortium for Space Mobility and ISAM Capabilities, better known as COSMIC. Though we generally frown upon acronym sandwiches, the staff here at N2K has agreed to let this one slide. COSMIC's goal is to advance technologies for in-space servicing, assembly, and manufacturing. The organization will focus on research and development of ISAM technology, incorporating them into missions, addressing gaps in ISAM requirements, and serve as a collaboration hub for organizations looking to adopt or commercialize ISAM capabilities. COSMIC is a direct result of the White House's National ISAM Implementation Plan, released in December, that directed NASA to establish such a group to, quote, improve communication between government, industry, and academia. We've linked to this plan in the show notes for you, and tune in later this episode for our interview with Michael Madrid from Starfish Space, all about ISAM tech. And we should note for full disclosure that Starfish Space is a partner of T-. Fleet Space Technologies has signed a $6.4 million Australian dollar contract with Australia's Defence Space Command, marking its first defence contract. The agreement will see Fleet's Centauri satellites used to develop and demonstrate a low Earth orbit, or LEO, satellite communication system focused on tactical communications and data transmission in areas with limited connectivity. And some more news from Down Under. Equatorial Launch Australia, or ELA, is expanding its partnership with US-based Phantom Space Corporation to develop mission profiles and launch requirements for multiple launches from the Arnhem Space Center. The 2 companies will collaborate on commercial and government launch opportunities in the Asia-Pacific region. This partnership follows ELA's 3 successful space launches for NASA over a 15-day period in 2022, which marked Australia's first ever commercial launches and the first for NASA from a commercial spaceport. Aerojet Rocketdyne has received a $67 million contract from Lockheed Martin to provide propulsion systems for the Orion spacecraft for NASA's Artemis 6, 7, and 8 missions in the 2030s. This contract builds upon Aerojet's work on earlier Artemis missions, including the uncrewed Artemis 1 mission last year. The company will deliver 3 additional sets of 8 auxiliary engines for Orion service module and 3 jettison motors for the crew module launch abort system. The contract strengthens Aerojet Rocketdyne's role in the Artemis program and the future of human spaceflight. It also comes on the heels of a $215.6 million cooperative agreement from the Department of Defense for Aerojet Rocketdyne to modernize and expand its facilities at 3 sites that produce rocket propulsion systems as part of efforts to help the DoD meet increasing demand for tactical missile systems. Firefly Aerospace is eyeing U.S. national security launch contracts for its medium-lift rocket that they are developing with Northrop Grumman. The National Security Space Launch Phase 3 contract will seek bids for less demanding missions to LEO to attract small launch companies working on medium-lift rockets. Firefly says that their new vehicle, which is based on Northrop's Antares rocket, will be able to challenge Rocket Lab's Neutron and Relativity Space's Terran R that are also expected to compete in the NSSL Phase 3. Firefly's next-generation medium-lift vehicle, or MLV, is targeting 2025 for its first flight. And as we've already noted, the 38th Space Symposium this week has seen plenty of updates and developments from national security space. Here's a quick rundown of some key issues for national security that we saw this week. The Pentagon's Chief Technology Officer has initiated a new effort to collaborate more closely with the commercial space sector in order to leverage rapid innovation for defense applications. Led by Lindsay Millard, the principal director for space, the initiative aims to integrate the commercial space economy's innovation ecosystem into joint warfighting concepts, accelerating capability adoption. General Chance Saltzman, Chief of Space Operations, has hinted at a new space-based capability that will be able to conduct, quote, full-spectrum operations in orbit by 2026. Saltzman's statement suggests the ability to conduct both offensive and defensive operations. This development reflects a broader shift in the U.S. military's approach to space, emphasizing the need to conduct a wide range of activities, including offensive operations. The Combined Joint Commercial Integration Office, established in March to help U.S. Space Command adopt commercial technology more quickly, is already attracting interest from companies, according to General James Dickinson. The office connects the work of the Joint Task Force Space Defense Commercial Operations Cell and the Commercial Integration Cell, both of which engage with private sector companies. The new office aims to use the commercial market to support U.S. Space Command and its allies and partners worldwide. And in fact, in tomorrow's episode of T-Minus, you'll hear from Master Gunnery Sergeant Scott Stalker, the Command Senior Enlisted Leader for U.S. Space Command, where he mentions this office and how Space Command is looking to engage more regularly with industry. So definitely don't miss that in tomorrow's show. Space Command's General John Shaw says the organization is pushing for on-orbit space operations by 2030. Speaking at the Space Symposium, General Shaw stated that Space Command plans to demonstrate space capabilities by 2026, such as on-orbit refueling, to allow satellites to maneuver at will over longer periods of time. The National Reconnaissance Office says they plan to have a new prototype of their space-based ground-moving target indicator, or GMTI, sometime within the next few months. NRO Director Chris Scalise says that the agency is already testing GMTI prototypes on orbit. The spy agency is working with the Space Force to develop space-based GMTI capability, expanding on the crewed plane and drone activity that it has used in the past. All right, that's it for our briefing for today. If you want to hear more about ISAM, we've got plenty more for you coming up next. My conversation with Michael Madrid, Director of Strategic Relationships at Starfish Space, a T-Minus launch partner, is coming up next. And a quick programming note from us now. Every Thursday, I'll sit down with industry voices in a segment all about the groundbreaking new products, services, capabilities, and business models emerging around the world. We're calling this segment the T-Minus Spaceport. Everyone you hear in this segment has paid to be here, and we hope you'll find it useful to hear directly from businesses about the challenges they're working to address and how they're doing it. In-space servicing, assembly, and manufacturing, or ISAM, is an area of satellite technology growth seeing a lot of interest as space organizations and satellite owners look to clean up dangerous space debris from orbit and to increase the longevity of the spacecraft they spent a lot of money to build and send to space. One company building satellite servicing vehicles is Starfish Space, and its upcoming vehicle is called the Otter. I recently spoke with Michael Madrid, Director of Strategic Relationships at Starfish Space, to tell us more about what Starfish is working on. And our discussion happened just after the company raised a $14 million Series A round in March this year. Here's our conversation. Congratulations on Starfish getting the Series A. That's great news.
Thank you. Yeah, we're very excited about it. There's a lot of good work to do ahead.
Yeah, could you tell me a little bit more about sort of the goals now with this new funding in hand, what Starfish is looking at to accomplish?
Yeah, we're really looking to accelerate the development and fielding of our first full commercial Otter, and that's really to chase after some of the exciting commercial customer traction that we've been able to generate in the last year. If you are kind of reading some of the headlines or keeping track of Starfish, one of the things we're talking the most about is our demonstration mission that's launching in a few months here in the summer of 2023. And that is that mission is called Otter Pup. It's a subscale spacecraft. And that was actually fully funded before the Series A. And we saw it as an important milestone to validate our technologies on orbit. But we also really wanted to step on the gas or continue to step on the gas for the full Otter vehicle. And this Series A is really going to help us do that.
Yeah, so let's dive into both Otter and Otter Pup, if you could. I guess this is a little bit of like, give me the pitch for what they do, because I love what Starfish's website has about Otter, and I'd love to learn more about both Otter and Otter Pup.
Yeah, absolutely. So for those who haven't seen the website yet, Otter is our servicing spacecraft. Basically, our goal is to dock with satellites that are already on orbit and provide them value through servicing. So that could be life extension, for example, in GEO, or end-of-life disposal of derelict satellites in LEO. And so what we've done is we've built a spacecraft that can capture or dock with any type of spacecraft on orbit. We don't require a pre-configured docking plate or a specific geometry. And we've also gotten the footprint of the vehicle down to about an ESPA-class satellite. So we're on the order of 200, 250 kilograms, and we're using only electric propulsion to dock with spacecraft and maneuver them. So we're highly efficient and much faster and more economical to build and launch. And the goal with the Otter Pup mission then is to validate our docking technology and also to validate some of our flight software. We've got an autonomous guidance and control product called Cephalopod and a relative navigation solution called Cetacean. There's a bit of a theme with the names. Our docking mechanism is called Nautilus. And so even though Otter Pup is a bit of a smaller spacecraft, we've got all three of those full-scale technologies on board, and we're going to dock hopefully with another commercial spacecraft in low Earth orbit this fall.
That's really exciting. And yeah, the autonomy is something that I was fascinated by, about how that's going to be used to make satellite servicing easier. Can you expand on that a little bit about how that will work?
Yeah, absolutely. And to be clear, right, in the first couple missions here, we'll definitely have humans in the loop. We'll have points in the concept of operations where we can have go, no go, and holds and things like that. So we're safety first, and we've got a lot of that in mind. But what we are sort of building for is a vision of push button type operations, where we can simply direct an Otter to go dock with a certain satellite. And then the flight software is doing all of the trajectory calculation, optimization. It's managing a complex abort framework. It's doing all of that on board the spacecraft. And that allows, a much more kind of what feels futuristic now, but what would be necessary for, really scaling these kinds of operations. And as one of our co-founders, likes to say, he would love it for to reach a world where we tell an Otter to go dock, and then a little bit later you get a text that says, docked, what would you like me to do next? And so we're kind of building towards that future where we can kind of flip the, ratio of humans to spacecraft. And that will only come once we can show that, docking between these two spacecraft autonomously is safe and reliable and routine.
That's such a cool idea. Almost like you just let it go do its thing, and it's got it from there. That will be so interesting to see that happen. For the very long-term vision for Starfish, like what's sort of on the game plan there?
Yeah, absolutely. So I kind of mentioned the three things we're building in-house, the flight software products and the capture mechanism or the docking technology. And we think those sort of underpin all types of autonomous interaction in space, and therefore all sorts of exciting applications within the ISAM or OSAM. There's a lot of different acronyms these days. But if we can really nail those core competencies, then we think that unlocks or accelerates all of these types of futures where we can assemble large structures in space, where we can support manufacturing operations. You could upgrade or repair satellites while they're on orbit. You can do refueling. And so all of those things are part of the medium to long-term vision. Like I mentioned, we're starting in the near term very specifically with life extension in GEO and end-of-life disposal in LEO, because we see sort of near-term business cases there and the ability to build a sustainable business. But, we're definitely all optimists and sci-fi geeks and space enthusiasts, so we can picture all the things that we want to do in the future as well.
What do you see as sort of like the biggest opportunity in ISAM? Not just within Starfish, but just in general? Like where could we make some really huge gains?
Yeah, I think that it comes down to, among other things, one of the answers that would stand out is unlocking a lot more value in the sort of infrastructure assets we've already sent to space. Right, so I've mentioned life extension in GEO, and for those unfamiliar, we've got these giant geostationary satellites that have lifetimes in the 15 to 20 years even kind of time frame, and they're big, gigantic, multi-thousand kilogram spacecraft, and often their payloads, whether that's for communication or whatnot, last even longer than their fuel does, because they're expending fuel to maintain their precise slot in orbit. And so these spacecraft go to a graveyard orbit at the end of their lives with a budget or a reserve left of fuel, just to be safe. But in many cases, they could continue revenue-generating operations for their owners for even more time. And so that's one thing that we can unlock right away. The Otter would dock with these satellites in GEO and use its own propulsion to station keep them or to correct inclination or even to move them to a new longitudinal slot so they can service a new market. And then the owners get that much more life out of them. And it's not that would ever necessarily replace the need for new satellites, for incorporating new technology on orbit, but it opens up a lot of flexibility for the operators and lets them really grow their business. And then in low Earth orbit as well, we're able to sort of unlock new value for constellations and for all this active infrastructure if we can remove some of the threats to the satellites from space debris or from satellites that fail to deorbit themselves and then are stuck in the operational plane and pose a risk or a threat to the rest of a very expensive constellation or mega constellation. So really we're looking to unlock kind of value in that dimension first. We're really excited to share and be very transparent with how the Otter Pup mission goes this fall, in the fall of 2023. And then, like I said, we are meeting with commercial satellite operators, meeting with government satellite operators to kind of explore and just make sure that the Otter service we're going to offer here in the next couple of years is something that's useful, is something that's meeting a market need. And one conversation I have, and to the greater topic of ISAM, is the difference between orbit transfer vehicles or OTVs and a servicer like the Otter. And so, at first glance, those are within sort of the same part of the space market and within the ISAM category. But I've been, explaining to folks recently that orbit transfer vehicles or OTVs, focus on what you might call the last mile delivery problem. And they help satellites get from the orbital insertion point where they get dropped off by a rocket to their final orbit or final destination. And that is very key, and that's really helpful, especially as we see more and more rideshare kind of launch programs where a lot of satellites are taking one rocket to space, and then these OTVs help them get to their final orbit without using up a bunch of their own fuel. But I've often drawn a nuance or a distinction there between the OTVs and vehicles like the Otter, where we'll go to space on our own, and then we'll fly up to and dock with another satellite that's already on orbit and start servicing it there. So there's a bit of a difference, and it's fun to kind of talk through how those are kind of complementary and again, all the opportunity that's ahead of us.
Thank you so much for your time. I really appreciate it.
My pleasure. Thanks for having me on.
We'll be right back. And welcome back. Move over, streetcars. Hyundai is shooting for the moon. South Korea's Hyundai Motor Group announced that it's developing a lunar rover. In a news release, Hyundai's head of R&D Planning and Coordination Center said the company is moving beyond land, sea, and air to space mobility. Hyundai Motor has research agreements with 6 South Korean institutes with interests in the aerospace sector. Among the partners are the Korea Astronomy and Space Science Institute, the Korea Atomic Energy Research Institute, and Korea Automotive Technology Institute. Hyundai's self-driving vehicle will be designed to explore the lunar surface, carrying 70 kilos of gear, and it hopes to be operating on the moon by 2027. Very cool. And that's it for T-Minus for April 20th, 2023. T-Minus is a production of N2K Networks, your source for strategic workforce intelligence. For additional links and resources from today's report, check out our show notes at space.n2k.com. Elliot Peltzman composed our theme song, mixing by Elliot Peltzman and Trey Hester. Alice Carruth is our producer. Our executive producer is Brandon Karpf. And I'm Maria Varmazis. See you tomorrow.
T-minus